In lesson 13, we're going to take advantage of what we learned in the last lesson about angles when parallel lines are cut by transversals, and we're going to apply that to the angle sum of a triangle. So one thing that you might already know is that for any triangle, no matter what the shape or size, the sum of the three angles is 180 degrees. So no matter if it's stretched out or even a right triangle, the angles will always add up to 180 degrees, and that's what this says here. And another thing that is mentioned here is that since this is a 90-degree angle, I know that these angles 7 and 9 are going to add up to actually be 90 degrees. Okay, so that's good, and you have probably used that in the past, but now we're going to take it a step further and we're going to prove it. So we're going to use what we know about angles, and we're going to actually prove that. So some of the facts that we'll use include the number of degrees in a straight angle. So a straight angle is just really a line, and you know, if we think about the angle that all of that takes up, we know that that is equal to 180 degrees. So a straight angle is 180 degrees. The other facts that we're going to use are all the things we learned about when parallel lines are cut by a transversal. So we learned about corresponding angles, alternate interior angles, alternate exterior angles. So we're going to look at a couple different ways that this theorem, the angle sum theorem, can be proved. Okay, so the first one is exploratory challenge number 1, and it uses this diagram that's been kind of carefully constructed. So we have a triangle. We have triangle ABC right here, and this is the triangle that we're going to focus on. And we want to show that these angles all add up to 180. So what we've done is drawn a line parallel to one of the lines of the triangle. So AB and EC are parallel. And we've also put another point D that's on the line that was extended from BC on that. So what we end up with is a situation where we're going to be able to find some angles that have the same measure and be able to show that these three add up to 180. So let's walk through this exploratory challenge together. So part A asks us to name the three interior angles of triangle ABC. So we're going to use the angle naming convention. So one of them would be angle BAC. So that would be this one here, starting from angle BAC. So it'd be this angle right in here. So go ahead and pause and name the other two angles in that triangle. Okay, so the other two angles are BCA, and that one would be right here, BCA, so it'd be this angle here. And then lastly, ABC, right in here, ABC. You could have something slightly different, because another way to write angle ABC is to write angle CBA, and that's the exact same angle. CBA is this angle, and ABC is also that angle. So you could have something slightly different, but those three angles you should have. Okay, so where's the straight angle? So see if you can name the straight angle. Okay, so the straight angle would just be the 3 points that are collinear, that are all laying in the same line. So the straight angle goes from here halfway around the circle. So the name of it would be angle BCD. Okay, so we're going to make use of the fact that this angle, BCD, is 180 degrees altogether. Okay, so let's go, I'm going to go to the next page and continue working on this diagram here. Okay, so we have the diagram, and something that I know you'll appreciate is I want to make naming these angles easier. So I wanted to work on naming them because that's something you need to know how to do. But for this proof, to make it more clear, we're going to name some of these angles. So we're going to let that angle BAC be angle 1, then we'll have angle 2 and angle 3. And those will be the angles in our triangle. So remember, we're trying to show that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 adds up to 180. We're also going to need to make use of a couple other angles. So we're going to have angle 4 and 5 also in our diagram. Okay, the thing I haven't done yet that maybe you have is we were told to extend these lines, these parallel lines. So I've extended them a little bit. And it might help you to turn your paper to the side so that the parallel lines are running horizontal for you to be able to see these angles better. Or maybe you're fine with them coming at angles like that. So these are our parallel lines right here. And we have two transversals. So we have a transversal here. We have another one here. Okay, so we know, okay, so let's just look at part C, and I'm going to have you pause and think about this. What kinds of angles are angle ABC? Okay, so angle ABC would be angle 2. Okay, and angle ECD. So angle ECD would be this one right here, ECD. So that would be angle 5. So what kinds of angles are angles 2 and 5? So go ahead and pause and think about that. And remember, we're going back to the last lesson where we learned all about these angles between parallel lines that are cut by transversals. Okay, so if my parallel lines are here, and my transversal is right here, this purple one here, then angles 2 and angle 5 are in corresponding positions, right? They're on the same side of the transversal, but they are, and they're both on the same side of the parallel line too. They're both below their parallel lines. So these would be corresponding angles. Okay, so angles 2 and angles 5 are corresponding angles. And what we know about corresponding angles is that their measures are equal. So we know that the measure of angle 2 is equal to the measure of angle 5. Okay, now look at part D on your own. What kinds of angles are BAC and ECA? First, what numbers are that, what numbers do they correspond to up on my diagram? And what does this mean about their measures? So go ahead and work on that. Okay, so what we have is angle BAC is angle 1. That's right up here. And angle ECA is angle 4. Okay, so angle 1 and angle 4. So if we look at angle 1 and angle 4, we can see that those are alternate interior angles. They're interior because they're between the two parallel lines. They're in between them. They're alternate because they're on either side of this transversal. So this time we're using a different transversal, so you can ignore the other one. Just look at this one. And angles 1 and 4 are on opposite sides of that transversal. You could use your transparency and prove this to yourself that those are equal in our diagram, but they are. So what we know is that the measure of angle 1 is equal to the measure of angle 4. Okay, so how's that all going to help us? Okay, so let's look at part E. We know that the measure of angle BCD, remember that's our straight angle here, this straight angle. We know that could be thought of as the measure of these three angles here, this one, and that one separately. So BCA, BCA, well, how they call it, ECA, and ECD, those add up to 180. So that would be angle 3, angle 4, and angle 5 add up to 180. So we could write that sentence like that. The measure of angle 3 plus the measure of angle 4 plus the measure of angle 5 is equal to 180. And the reason that we know that is the angles are in a straight angle equal 180. Okay, so that's great. I know that those are 180, but those are not the angles that are in my triangle. I need to show that the measure of angle 1 plus 2 plus 3 is equal to 180. So I want you to pause and think about how you could use the information that we have gathered here to do that. Okay, so we want to know 1, 2, and 3. So I'm going to just rewrite this number sentence here. So measure of angle 3 is in our triangle. So I'm going to keep that one. And it's also part of the straight angle up here. The measure of angle 4 is equal to, I know because it says it over here, is equal to the measure of angle 1. So I can just substitute the measure of angle 1 for the measure of angle 4 right here because they're the same number, right? They're equal. And I don't change my number sentence at all. In the same way, the measure of angle 5 is equal to the measure of angle 2, so I can substitute that measurement right there. And when I do that, I know that that's still 180 degrees. And the reason I can do that is substitution. Okay, so I can complete this proof just by writing down my reasons for these steps. So this is the sum of a straight angle. I don't have much room here, so I'm really abbreviating. And this one was just substitution. Okay, and we gave reasons up here, the alternate interior angles and the corresponding angles. So we've given a reason for every step of the way, and we've done what we set out to do, which was to show that the measure of angle 1 plus measure of angle 2 plus measure of angle 3 is equal to 180. Okay, so that's pretty cool using what we've known, what we learned about the angles when two parallel lines are cut by a transversal. All right, so there is a slightly different version of this proof, and we're going to look at that right now. Okay, so in Exploratory Challenge 2, you just have a slightly different diagram to work with. So I'm going to let you study it right now, and then we'll go through some of the prompts together. Okay, you've had a chance to look at the diagram for a minute and read the descriptions. So we know that line L1 and L2 are parallel lines, okay, and there's several points named on the lines here. So let's just move on to part A. So part A asks us to name the triangle because we're looking for a triangle that we can then prove that the angles add up to 180. So if you haven't yet named the triangle in the figure, go ahead and do so now. Okay, so our triangle is triangle BCF or BFC or CFB, however you want to name it. You just name the vertices in order like that. So we have triangle BCF right here in the middle of our diagram. right down here. And our next prompt asks us to name a straight angle that will be useful in proving that the sum of the measures of the interior angles in the triangle is 180. So we're focused on this triangle. And notice I've colored a couple of my lines here. We have two transversals again that are cutting through these parallel lines. All right, so I'm going to ask you just to take maybe another 10 minutes and think about parts B and C. So part B is to name which straight angle would be useful in proving that the sum of the measures is 180, and then to write a proof using that. So I'd like you to, if you haven't yet, spend a little bit of time now and do that. Okay, so hopefully you have stretched your brain a little bit on this one. So I'm going to go ahead and give you a version of this proof that that works here. And so part B asks us to name a straight angle. So I'm going to name this one here, GFE. So the measure of angle GFE is equal to 180 because it's a straight line right on there. And I'm going to go ahead and once again simplify this proof by naming my angles. So the angles within my triangle are 1, 2, and 3. And then I'm also going to name the angles on the straight angle. So I've got angle 4 and angle 5 there. So what do I know? I know that angle 3, 4, and 5 add up to 180, but I need to know that 1, 2, and 3 add up to 180. So I'm going to need to know can I substitute one of these angles down here, either 5 or 4, for 1 and 2. Okay, 3 is already in my triangle. So let's think about this. So I've got angle, that's not what I meant to do. Oh yeah, I know that 3, 4, and 5 add up to 180. It is what I meant to do because it's a straight angle. So the measure of angle 1, can I find on my diagram another angle that's equal to the measure of angle 1? Okay, so the angle that's equal to 1 would be angle 4. Okay, so angle 1 and angle 4 have the same measures. What would be the reason? What type of angle are they? Okay, well, they're on opposite sides of this transversal here, but they're inside the parallel lines. So that means they're alternate interior angles. Alternate meaning on either side of the transversal, interior meaning between the parallel lines. So they're alternate interior angles. Okay, so I also need to find something that I can substitute for angle 2. So which angle would be equal to angle 2, which measure, and why? Okay, so angle 2 has the same measure as angle 5, and the reason for that would be this is a transversal here, this green one coming through. These angles are inside the parallel lines. That means they're interior angles, and they're on opposite sides of a transversal, so they are alternate interior angles. So they're exactly the same type of angle, but on a different transversal. Okay, so now I know I can substitute the measure of angle 1 in for 4 and the measure of angle 2 in for 5. So let's see what that looks like real quick. Need to get more room here. So here's my notes again. So here's where we are in the proof. So now we need to do our substitution. So I'm going to rewrite that equation that those angles add up to 180, and then I can begin substituting. So I'm going to substitute the measure of angle 1 for the measure of angle 4 since they're equal. And then I'm going to leave the measure of angle 3 in my equation. substitute the measure of angle 2 for the measure of angle 5, and I know that that equals 180 degrees. Okay, so the reason that I can give for the reason I can do that is just substituting. I'm substituting an equivalent number or value in for something else. So I've done what I've set out to do, which was to show that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180 degrees. And that was based on this diagram here. So we showed that these three angles added up to 180 degrees. So that was a slightly different setup. The diagram was a little bit different, but obviously the result was the same because we know that this is a fact, that the angle sum of a triangle is 180 degrees. All right, so you're going to have some proofs like that, similar to that, not proving the angle sum of a triangle, but using transversals to determine unknown angles. So I encourage you to give reasons along the way for each step that you do, and mark up the diagram if it helps you. I find it really helpful to number the angles rather than having to use 3 letters to name everything. It gets really kind of a drag. So, all right, good luck with the exit ticket and the problem set with that. I think you'll do fine.